Okay, so the last video we talked about resistors in series. How do they behave? Well, they behave as one big resistor. You add them up. So I'm actually going to introduce to you now the concept of Ohm's law and the concept of an ohmic resistor. And Ohm's law, I just showed you before a little bit here that it's this, you're basically saying that the voltage drop is equal to the current times the resistance. But really a better definition of that is to say that in an ohmic resistor, sorry about that, in an ohmic resistor, that the resistance is constant. So here's your resistance like this, okay? So the resistance is going to be change of the voltage over the current. Why is that a better definition? Well, the point is an ideal resistor will not change its resistance. So that's not a reality, but in ideal it won't. So the idea is that as I crank up more voltage, I'm going to get more current because these two are directly related. This is constant. So when I talk to you guys about, dealing with relationships and variables and solving, what happens to this as these are changed, we always put the one that's constant on the left and we put everything else over here. So I say, okay, crank up the voltage, I want more current. I want more current, more voltage. Okay, so they go together. But we really use it in this way, V equals IR, to find out the voltage drop across a resistor. So the way that this works is you would set up a battery like this. So in this case I had 6 ohms. So let's just say that I had a battery here that was, I don't know, let's just say it's 60 volts, okay? And I had a resistor here, just one resistor, right? And I want to know, okay, what's the voltage drop across that resistor? Well, the way that we apply Ohm's law is that we really have to get it down to one battery and one resistor. Okay, so let's say that resistor was the 6 ohm resistor that we had over here. Let's just say it was over here. So I want to know, okay, well, this is just a series circuit. From before, what I taught you was that we know, okay, before the first element it's 60 volts, across the last one it's 0 volts. So without doing an equation, you knew that the voltage drop was 60. Well, let's just prove it. So let's say, okay, delta V equals IR. Okay, and let's find the current first. What's the current? Well, what do we have? Let's go back to our problem-solving method here. Well, I have the voltage drop here, the battery, okay? I have the resistance. I want to find the current, right? Okay, so the current leaving the battery, that's what we're going to call this. When we have one battery, one resistor, the current leaving the battery, which is I. So what is that? Well, I equals V over R in this case. Okay, so in this case, we're going to say 60 over 6 or 10 amps. So the current leaving the battery is going to be 10 amps. And it's series, so we know that that current is 10 amps everywhere, right? 10 amps, 10 amps, 10 amps, 10 amps, etc. Right? Fine. So that's how you find the current. Use Ohm's law. Okay? Now, that's a simple example because we have one battery, one resistor. But when we get into series circuits, and I'll show you in a minute, we often have to break down these resistors to get that one resistor, that one equivalence, so we can go back to this situation and find out what the current's going to be. Okay, so in the next video I'll talk to you about how to break down those resistors to find the current and then find the voltage drop across each one.